The pulse speed is defined as, just very simply, how fast you would have to run alongside this spring to catch up with the pulse, to keep up with the pulse. Now, it turns out that that pulse speed depends on only two things when you're dealing with a transverse pulse. It depends on the restoring force, how hard we're pulling things back towards equilibrium. And the second thing is how hard it is to get them back to equilibrium, how massive they are. Now, if you're talking about a football player, you can talk about the mass of that football player. It's a unit, okay? Now, if you have something like a rope or a spring, talking about the mass of the whole spring doesn't really give you the information you need. Because I could have a spring that was a certain type of spring. If I had a mile of it, it would have half the mass as if I had 2 miles of it. Both springs would act the same, so the total mass is not going to give me what I need. What matters is the mass density. How much mass there is in 1 unit of length, typically a meter of length. And we can go through some fancy mathematics to derive this. I don't want to take us there. The final answer is that the velocity of the pulse depends on the tension in the spring or string or rope and the mass density of the spring or string or rope in this form here.